So in section 1, we talked about an identity, and it's an equation that's true for every number in the domain of an equation. So for example, we know tangent of x equals sine of x over cosine of x. So that means for no matter what value we use for x, it is always true. So in section 2, we're going to be using identities in algebra to simplify trig expressions to get a new expression that has no fractions and contains the least number of terms possible. We're also going to be verifying trig identities. So we need to review some of the identities we covered in section 1 and talk about a couple new ones. And these you're going to have to memorize or keep these notes handy when you're doing your assignments. So let's go ahead and review the ones we talked about in section 1. So we went over our reciprocal identities and our ratio identities or quotient identities. So that's what we already talked about. We also talked about our Pythagorean identities. Now we talked about the sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant squared, and we talked about cotangent squared x plus 1 equals cosecant squared x. But we can manipulate these equations to get one of our other trig functions alone. So we can subtract sine squared and get that cosine squared x equals 1 minus sine squared. And we can keep going. So the other two below are just manipulations of the three we've already talked about. And these are going to be important for when we're simplifying and verifying trig identities. So let's start with simplifying trig expressions. So our first example we want to look at is the expression tangent of x over secant of x. Well, we're going to use our ratio and reciprocal identities to simplify this. So we start with tangent of x. I know I can rewrite that as sine of x over cosine of x. And then in our denominator, secant of x can be written as 1 over cosine of x. Now we're dividing two fractions, which you always rewrite the division with fractions as multiplication. So we'll leave the numerator alone, so sine of x over cosine of x times the reciprocal of the denominator, which gives us cosine of x over 1. Now that we've written it, the cosines will cancel and we'll be left with sine of x as our simplified expression. Next, we want to look at tangent of x times cosecant squared of x minus tangent of x. Well, the first thing I can recognize is that both of our terms have a tangent of x in them. So we're going to factor out that tangent of x. So we factor out tangent of x, we're left with cosecant squared of x minus 1 in parentheses. And if you look up above, under one of our Pythagorean identities, cosecant squared of x minus 1 is the same thing as cotangent squared. So this becomes tangent of x times cotangent squared of x. Now we want to see if this will simplify further. So using our ratio identities, we know tangent is sine of x over cosine of x times cosine squared of x over sine squared of x. And now I recognize one sine of x is going to cancel from my numerator and my denominator, and one cosine of x is going to cancel from a numerator and denominator. So it leaves me with cosine of x over sine of x, which using a ratio identity gives us cotangent of x. And that would be our simplified expression. Next, we want to simplify cosine of beta over secant of beta plus sine of beta over cosecant of beta. Now, before we would try to get these to be single fractions, we want to see if the fractions will simplify on their own using reciprocal identity. So we're going to leave the cosine of beta alone. Secant is the same thing as 1 over cosine beta, plus leave the sine of beta alone over cosecant of beta, which becomes 1 over sine of beta. Now we are dividing using fractions, so we're going to read it as multiplication. So the cosine of beta is left alone, times the reciprocal of the denominator, which gives us cosine beta, plus sine of beta times the reciprocal of the denominator, which gives us sine of beta. Cosine beta times cosine beta is cosine squared beta. Plus sine times sine gives us sine squared beta. And this is one of our Pythagorean identities. Sine squared plus cosine squared, or cosine squared plus sine squared, is 1. And that's our simplified expression. It's just 1. Now we're going to simplify cosine of theta over sine of theta plus sine of theta over 1 plus cosine theta. Now, since our expressions already contain sine and cosine, there's really no way to simplify each fraction on its own. So we're going to go ahead and get common denominators. So to get common denominators, we have to multiply our first fraction by 1 plus cosine theta. And we have to multiply our second fraction by sine of theta. So the numerator of our new fraction is going to be cosine of theta times 1 plus cosine of theta plus sine of theta times sine of theta, which is sine squared of theta, all over sine of theta times 1 plus cosine of theta. It doesn't make any sense to distribute into our denominator in case something ends up simplifying further down the road. We are going to distribute the cosine into the parentheses though, so we get cosine of theta plus cosine squared theta plus sine squared theta in our numerator. Still over the sine of theta times 1 plus cosine of theta. Using our Pythagorean identity again, cosine squared theta plus sine squared theta is going to become 1. So we get cosine theta plus 1 over sine of theta times 1 plus cosine of theta. Order of addition does not matter. So cosine theta plus 1 and 1 plus cosine theta are the same. So they will cancel. We'll be left with 1 over sine of theta. And using our reciprocal identity, 1 over sine of theta is cosecant of theta. So cosecant of theta is our simplified expression. So simplifying trig expressions is very useful because it makes our complex expression easier to deal with if we wanted to evaluate it. So another type of problem I already mentioned is to prove that an identity is an identity. So establishing these lets us use them to simplify expressions. So when we are verifying trig identity, there's a couple strategies you want to use. The first is to use previous identities in algebra to turn one side of the equation into the other. And the second is to write everything in terms of sine and cosine, which we've been doing already with the simplifying expressions. So it's going to continue to when we verify trig identities. So our first example is we want to verify that secant of x plus tangent of x equals 1 plus sine of x over cosine x. Usually when you're trying to verify an expression, it's easier to simplify the side that contains fractions instead of trying to rewrite a side that doesn't. So we want to verify that 1 plus sine of x over cosine x simplifies to secant x plus tangent x. The first thing I'm going to do is I can take 1 plus sine of x over cosine of x and split that numerator into two fractions. So we get 1 over cosine of x plus sine of x over cosine of x. Now we can use ratio and reciprocal identities to simplify. 1 over cosine of x is secant of x plus sine of x over cosine of x, which is tangent of x. And we have verified that 1 plus sine of x over cosine x is equal to secant of x plus tangent of x. Okay. Now we want to verify that 1 plus cosine of x minus cosine squared of x over sine of x equals sine of x plus cotangent of x. Again, easier to simplify the side with the fraction. So what I'm going to start with is I'm going to replace cosine squared of x using one of my Pythagorean identities. So we know that cosine squared of x is the same thing as 1 minus sine squared of x. And that comes from that first page under the sine squared x, cosine squared plus sine squared equals 1 Pythagorean identity. All over sine of x. Distribute the negative into our parentheses. We get 1 plus cosine of x minus 1 plus sine squared of x over sine of x. 1 minus 1 is going to be 0, so we're left with cosine of x plus sine squared of x all over sine of x. Similar to the last example, I can now break our single fraction into 2. So we can write it as cosine of x over sine of x plus sine squared of x over sine of x. Well, cosine of x over sine of x is cotangent of x. And sine squared divided by sine will leave me with 1 sine. So we get plus sine of x. And we have verified that we get cotangent of x plus sine of x, or sine of x plus cotangent of x. Order of addition doesn't matter, so it doesn't matter which order I write these in. So now we want to verify that tangent of x minus cotangent of x over sine of x cosine x equals secant squared x minus cosecant squared x. So my first step, I'm going to break up my fraction, write it as tangent of x over sine of x cosine x minus cotangent of x over sine of x cosine of x. Now I want to replace tangent and cotangent with their ratio identities, since I want to get sine and cosine. So we get sine of x over cosine of x all over sine of x cosine of x minus cosine of x over sine of x all over sine of x cosine of x. Okay. Dividing a fraction by something, so we're going to rewrite it as multiplication. Leave the numerator alone, so we get sine of x over cosine of x times the reciprocal of the denominator, which becomes 1 over sine of x cosine of x minus cosine of x over sine of x times 1 over sine of x cosine of x. So if I look now, a sine of x will cancel from the numerator and denominator, so we're left with 1 over cosine times cosine, which is cosine squared of x, minus a cosine will cancel, so we're left with 1 over sine of x times sine of x, which is sine squared of x. Using our reciprocal identities, 1 over cosine is secant, so we get secant squared of x minus 1 over sine, which is cosecant, so cosecant squared of x. And we have now verified our identity. Next, we want to verify cosine of y over 1 minus sine of y equals 1 plus sine of y over cosine y. Now, because both sides are fractions, it's a little bit more difficult to verify that two fractions are the same. So what I'm going to do is I'm actually going to make one side not a fraction. So I'm going to multiply both sides by cosine of y. And when I do that, I get cosine squared of y over 1 minus sine of y equals 1 plus sine of y. Now it's a bit easier to verify that the left side can simplify just to 1 plus sine of y. So I can use a Pythagorean identity. Cosine squared of y can be rewritten as 1 minus sine squared of y over 1 minus sine of y. Now I can't just cancel a sign from the top and the bottom because I have that 1 minus in front. But you can think of 1 minus sine squared y as the same thing as 1 minus x squared. 1 minus x squared is an example of a difference of squares, which means I can factor it as 1 minus x, 1 plus x. I can do the same thing with my trig function. I can rewrite 1 minus sine squared as y. I can factor it as 1 minus sine y times 1 plus sine of y, all over 1 minus sine of y. Now I have a 1 minus sine of y in my numerator and denominator, which can cancel, and we're left with 1 plus sine of y. And I have now verified my identity. Our last example, we want to verify that cotangent squared of y minus cosine squared of y equals cotangent squared of y times cosine squared of y. So I'm going to verify this identity by simplifying the left side. So I'm going to start with replacing cotangent squared of y using its ratio identity. I can rewrite it as cosine squared of y over sine squared of y minus cosine squared of y over 1. Now we have two fractions. We want them to have common denominators. So I'm going to multiply the cosine squared of y by sine squared of y in the numerator and denominator. So we're going to get cosine squared of y minus cosine squared y sine squared y all over sine squared of y. Now my numerator, both terms have a cosine squared, so I'm going to factor out the cosine squared, and we're left with 1 minus sine squared of y, still all over the sine squared of y. I can now use a Pythagorean identity and replace 1 minus sine squared of y with cosine squared of y. So we get cosine squared of y times cosine squared of y over sine squared of y. Now that we look at our fraction, if we notice, I can rewrite cosine squared y over sine squared of y, since that is the fraction for cotangent. So we get cotangent squared of y times our remaining part of our numerator, cosine squared of y. And we have now verified our identity. It's very important that when you're verifying identities, you take your time and you try not to overcomplicate your simplification when you're verifying. Use the reciprocal identities, the ratio identities, and our Pythagorean identities. Don't overcomplicate the process when you're doing these on your own.